referenced ignition and CPU 95 in particular. I think it's going to be very important for everybody to be fully up to speed on how crankshaft reference ignition systems operate and the sort of the fundamentals of that. Certainly as the new NGI 5000 and 3000 are rolled out here in the coming 12 to 18 months. So Tom is in a great position here. He's having serviced these products for many years to give you that fundamental background. So Thomas, the floor is yours to on crankshaft reference ignitions and CPU 95.
All right, David, thank you. So we'll get started with crankshaft referenced ignitions and get right into it here. So the systems that we sell today that are crankshaft reference are the CPU 95, the 95 EVS, which is a continuation of that product line, and the CPU 2000. This chart goes to show what we're looking at, Ultronic 2, and how it's evolved through the CPU 2 and CPU 2000, and we'll have the CPU 5000 shortly here. And then the Ultronic 3 and its variations of negative ground coils, CPU 90, CPU 95s, and the CPU 95 EVSs have all evolved. And the Ultronic 5s, those are mostly CD1s and CD200s. So what we're going to be talking about today are the large bore slow speed engines with the CPU 2000s and the medium and high speed, which is the bulk of our sales with the crankshaft reference systems. And those are the CPU 95s and 95 EVSs. CPU 90s are obsolete for some number of years now, but that's the product evolution going back. So the CPU 95 is microprocessor based crankshaft reference, and we'll talk to you about what that means. Digital ignition for medium-sized natural gas engines, optimizing combustion and performance, maximizing spark plug life. Spark plugs are pretty expensive on all these engines, so that's a big factor for costs. And it offers proprietary primary and secondary discharge diagnostics to minimize engine downtime. So the diagnostics are one of the biggest things with the ignitions in the last 30 years or so, because with the old magneto style ignition, when the engine didn't run, it was either fuel or it was air, and you had to figure out which one it was. So you had to get meters out and try to figure out why your Ultronic 3 wasn't firing, or was it your fuel system? And with the CPU 95s and the diagnostics, it pretty much tells you right on the screen what's going on and whether it's the ignition or whether it's something else. So the 95 gives you an intuitive, user-friendly display for ease of system access and control. And we have had a number of different display modules. And what we have now is what we call the enhanced display module. And that's a larger screen, and that we've had that for almost 10 years now. And it also gives you USB connectivity, so it makes it very easy to program the unit. It also includes graphing and custom output mapping. So it's system simple retrofit using the original coils from the Ultronic 3 CPU or CPU 90s. CSA certified like all our systems for Class 1, Div 2, Group C and D areas. Also has ATEX and SAA approvals. This is part of the application list designator for the ignition modules. We just wanted to describe to you what the different models are and where they're used. And if you start at the top here, the standard units, CPU 95s, are the 950s. And the 3 that you'll see is the 8-cylinder, 16-cylinder, and then the 18 is commonly used on some of the larger number of cylinders. When you get above 16, there's some 18-cylinder European engines. And then we also have a dual capacitor 18, which is the 952, and that is used again on some of these European engines. Dual capacitor, because of some of the firing angles, you have to have the second cap. The 952-20, again, dual cap for the 20-cylinder engines. And then we get into VeraSpark, and the 958-16 was the first VeraSpark product that we had, and we'll show you what that is. And then we go into the enhanced VeraSpark, and that is the 963-16A. So that's a little bit different. Now, when you get into the CAT systems for CAT EIS coils and the engine block connector, this is where the coils are underneath the valve cover. So now we have an EIS, and that is, you can see here, this is the A. This is the calibration for the standard coils. When you get into the E designation, that is the calibration for Spark Diagnostics for the coils that are under the valve cover. So there is a difference, and you have to use the right module. When you look at the application list on the next page here, you'll see that for CAT applications, a standard 3516, we've got the 950-16, or you can use a standard enhanced VeraSpark, EVS. SI low emissions, that's where you would use the standard VeraSpark or the enhanced VeraSpark. And then the EIS low emissions, the only option we have is that 963-16E. Those are the ones for the coils underneath the valve covers. So the CPU 95 output module that you see in the center here, that's the main unit, and that's where all your connections go for your Hall effect, your gear tooth, your reset, and then you have a communication over to your enhanced display module. And that currently, I believe that's the only one we're selling right now, and that's the 791-909-1. And when you use this one, we have the option of taking a 4-to-20 into it directly. The miscellaneous input can go in here directly. We have Modbus and USB that can go into the display module. So the current display module addresses all the issues and provides improvements over everything we've released in the past. So it's a great product, and it's been out for many years, working very well. The output module has 8-to-20 ignition outputs, and we saw that in that application list. Now, the whole idea of crankshaft referenced is that, in the past, when you had a magneto drive and you had an Ultronic 3 or any other ignition on it, the solid state ignition, like an Ultronic 3, only can be manufactured to plus or minus 1 degree of the back cover, which is the timing of the engine. But when it's a 4-cycle, 1 degree on the back cover means 2 degrees on the crankshaft. So that means that's plus or minus 2 degrees of timing. So if you were to check your timing from cylinder to cylinder, you could get plus or minus 2 degrees on any one cylinder, any group of cylinders. And when you calculated in all the gear lash or chain drives that drove the magneto drive, that plus or minus 2 often could be plus or minus 3 or even 4 degrees. So your ignition timing from one cylinder to the next can have quite a bit of variability. And, obviously the power that comes out of an engine depends on where the timing is. If it's too early, you don't get as much power. If it's too late, you don't get as much power. And all those factors affect emissions also. So once you go to a very accurate ignition, it stabilizes the main event of combustion, which is the spark. So because on the crankshaft, which is connected to the rods and the pistons, there's no movement there. So those positions of the pistons equate to certain degrees of the crankshaft. And when we start to measure on the crankshaft, and when you look at the tooth or hole pickup, we either drill holes, like in where it's a integral engine, a big engine that does not have a ring gear. We drill holes, and that's typically like 180 to 360 holes around the periphery, or if it already has a good ring gear on it that's not all chewed up, you can use the ring gear for sensing. So once you do that and you program the ignition, it's going to count so many holes or ring gear teeth and fire, depending on the firing angles, count so many more teeth and fire. So it's going to be extremely accurate. So that is proven to be, the state of the art technology in ignition systems because it is so accurate. And we also use a reset pickup, which means every revolution you get a reset and it starts the count all over again. Starts firing number one and then count so many holes, fire number two, and then all the way around the circle. When it gets the reset, it says reset, start over in that circle again and start firing on the A output or the first cylinder in the order. And pretty much a standard way to do things nowadays. It's been done for over 35 years or so. The reset pin fabrication is typically just done out of a ferrous metal bolt, quarter 20 typical, and you just use it on a grinder and make a nice flat-headed end for the pickup to read, and use a jam nut on it, and very quick and easy to make that. The input and output structure, we have 2 mag pickups for reset and crankshaft position. If it's a 4-cycle engine, we need a Hall effect to only acknowledge the reset on every other revolution, which would be on the compression stroke. We have a shutdown condition switch, which is either shorting the shutdown lead or it's a low voltage input for shutdown. We have a miscellaneous input so that with an external switch, you can control the timing. You can put a retard in there. Maybe you have a dual fuel application. So with a switch input, you can change the timing, or you can make it have multi-strike or a higher energy level with that switch position. So those are all selectable through the programming. We also have a 4 to 20 milliamp timing control as an input. That's not too typical on the CPU95, but it's available. The 4 to 20s are more commonly used with an engine control system on the integrals, which is CPU 2000. And we also have a USB on the back of the display module. EDM is Enhanced Display Module, and that's Modbus, and you can use the USB to program the unit. It's a quick, easy connection between your laptop and the USB cable to the back of the display. And then we also have on the enhanced display module an RS-485 connection to continually monitor the system if you choose to do that. So the mag pickups, it's our typical 691, 118-X, different lengths. 2-wire, non-powered, 5/8/18. It requires a pretty tight gap of about 15 thousandths. So you have to make sure what you're monitoring, your flywheel doesn't have a lot of run out and your gear teeth are in good condition. The Hall effect pickup, same format, 5/8/18, but it's a 3-wire powered pickup. It's got plus and minus power, and then it's got the sense inputs. So when a magnet is present, that's going to give you an on time, and typically that's how we window or acknowledge the reset on the compression stroke. So typically this would be mounted at cam speed or on the magneto drive or some other speed that's going to allow the reset to occur within that window of on time of the Hall effect. So the IO structure, we have anywhere from 8 to 20 outputs. We have a fire confirm. That's used typically for fuel permissive. Almost all these engines should be using some manner to purge the engine, which means you roll the engine with no fuel and no ignition. And then once it's rolling and it sees a certain RPM, you add the ignition. Maybe you unground the shutdown condition switch, and then it starts to fire, and then the fire confirm switch internal to this device turns on, and that allows you to turn your fuel on. So you always have ignition before the fuel so that you don't have an exhaust explosion. We also have RS-45 communications, and with the enhanced display module, you can connect right to the back of it and get your RS-45 Modbus. These are the connections inside the ignition module. And going left to right, you see two switches on the far left. User input close to stop the ignition, and that's the shutdown input. That's a logic level. There's not much current through the switch, so typically that's through some automation system, or it could just be a toggle switch. And then you have the miscellaneous input, and again, that can be through an automation system, or it can be through a toggle switch, whatever you choose to put into it. Then we have next to that 3, 4, and 5. Those are the relays that would be energized on the alarm output, the fault out, and the fire confirm output. Then we have communications, and you can see this ring here, which is the shield, and that is for a 4-wire cable plus shield, and that's the serial communications that goes out to the display module, and then the power, which is very important that that power comes from this unit through those 2 wires. So you have a total of 4 wires that go out to the display module. Then we have gear tooth pickups and reset pickups wired in here. Then we have the 4-cycle pickup, and most of the CPU95s go on the medium speed, like CATs, Waukesha's, Superiors. So typically those will all have a Hall effect on them also. And then you have your DC power. And the DC power, with the standard 95, they draw less than 2 amps, so you use a 5 amp supply. But when you go into the CPU95 EVS, you're going to need at least a 10 amp supply. So there's details on that in the installation instructions. So the EVS has a lot more power that can be delivered to the spark plugs, but it also draws more power from the DC system. So the features, comprehensive display capability, spark characteristic control, global and individual cylinder timing control. And individual cylinder timing control, it's not very often that anybody needs to do that, but some people with engine management systems want to retard individual cylinders. Typically, we like to just do global timing, individual cylinder timing. And you really have to know what you're doing in order to get into that. We also have diagnostic test and trending capabilities on the display, serial communications, easy retrofit from a 3 CPU, and 90, uses the same coils, and certified for hazardous areas. The 791-909-1, this is what the display looks like. The older ones, the 902 and the 908, had smaller displays. But in that display, we give you a lot of information, and we're going to show you a lot of the screens. So it gives you the system status and mode. This one's actually showing you the spark voltage, but it will also give you the system status and mode, normal running information, diagnostic messages, timing status and control messages, spark reference number graphs, setup choices and messages. This is a typical screen when the engine is running normally. At the very top, it tells you it's the CPU95. Top left, it tells you it's firing. Over here, it's energy level 1, single strike, and that might be multi-strike otherwise. Your 4 to 20 value coming in, anywhere from 4 to 20 milliamps. The CPU95 memory code, P2A360 FS1. These are typical for people familiar with the CPUs. Engine ignition timing, and also the engine RPM. So from one screen, you can walk up to it and say, everything's good, we're all running fine. So the system status, we have basically, as the engine starts up, a ready, syncing, firing. And when it's ready, we see that there's no faults. It's ready to roll. Syncing is when you're seeing an RPM, in this case 100 RPM, and it's synchronizing, and it needs 2 revolutions to see the reset, the gear teeth, and make sure that everything is syncing up properly and it's reading the right number of teeth, and then it'll go into a firing mode. The other screens you'll see is a stalled screen, and that's when there's a loss of rotation with no shutdown or fault. So something else caused it to stop firing. Like if you just cut off the fuel, it would give you a stalled condition. Shutdown condition, that's when your low voltage or shutdown lead has been grounded or the ignition would stop. Then you have the diagnostics. You have two levels. You have a warning and a fault. And it's going to tell you, after you press diag, it's going to tell you what that fault is. The spark characteristic control, it allows higher energy or multi-strike to be used when necessary. Double strike is selectable on and off. And there's 3 different energy levels, and we control that with the voltage going out to the coil. It's either 140, 160, or 180 volts. So it gives you 75, 100, or 125 millijoules. And this is pretty typical of the Ultronic 3, somewhere around 100 millijoules. So the 3 ran most of the engines, but if you got into an issue where you had poor quality fuel, biofuel, any kind of gas that it doesn't have a good enough BTU content, then sometimes giving it extra energy would allow you to ignite that mixture. So the trade-off of that is that uh, if you put a lot of energy and multi-strike into these, your spark plug life will not be as good. So you always want to use the lowest energy setting possible for the conditions, and that will give you the longest spark plug life. So the timing control capability, keypad, you can go in there and change the timing any time you want. You can do it serially with communications, analog with the 4 to 20, timing versus RPM. A lot of the superiors always had a timing versus RPM curve, all the way from the old Ultronic 3s with the T connector and the 381-610 box through the CPU 90s. We programmed it in, and the 95s, we just program it in, and that's all programmable from the terminal program. We also have a miscellaneous input, which can give you a one-step or global timing change. Miscellaneous input, it's application specific. It can be programmed to do whatever you'd like. 3 control features can be configured to that grounding of the switch. That's one-step timing, spark energy control, and double strike control. So in the program that we'll show you, we'll show you where that is all set. We also have a 2-tier diagnostic structure where we have warnings and faults. Warnings are less severe, non-emergency diagnostics like an open primary. You might lose the cylinder, but if you choose to, you do not have to shut the engine down. And when you have a warning, it prompts you to view the diagnostics. It faults the alarm output, and whatever you wire the alarm output to, which could be a horn, bell, relay, call out system, whatever it is, or you could wire the alarm output to a shutdown system. It's your choice. So if you lose a cylinder because of an open primary and you want to shut it down, you have the option to do that. But it doesn't that fault does not shut down the ignition directly. And then we have faults. These are more severe emergency diagnostics that demand immediate action, which is like a missing reset, overspeed, uh, or missing more than 5 teeth or holes. If you would have one of these faults, gives you a fault message, prompts you to view the diagnostics, faults the alarm and shutdown outputs, opens the fire confirm, which should turn your fuel off, and it shuts down the engine, and the ignition actually turns itself off. So in this case, this is an example of a gear tooth fault, pickup fault as missing pulses. Reset pickup. Obviously, if you don't have a reset, you can't index and you can't fire your outputs. If you don't have the right gear teeth, you can't fire at the correct timing. So both of these are something that are a fault and would shut you down. More fault shutdown diagnostics or the Hall effect pickup. Ring gear fault, and this one You can see on the right here that shows you that you've only read 351 teeth. And typically that would probably be 360. So if you miss enough teeth, it's going to shut you down also. And we also have a built-in overspeed that's selectable and settable from the keypad. And if it does go into that overspeed, you're going to shut down. Primary and secondary discharge diagnostics, it's non-intrusive. It uses the coils themselves with some feedback to look at that discharge. Um, it gives you a concise, plain language indication of the fault just on the display or serially, and you have user adjustable thresholds, enables the system to use on any engine. The diagnostic functions give you open and shorted primary wiring and coil issues. You can look for low and excessive voltage demand driven by spark plug lead condition or combustion anomalies. You can use it to assist in determining proper point to change your spark plugs, and automatic energy adjustment can lengthen spark plug service life. So the reference number, it's a unitless number ranging from 0 to 255. The manual gives you some examples of what's typical on blue coils or red coils. So when you start out, you can press a button and it will, through the terminal program, and it will normalize all the coils. So for example, if you put one of these on and you use brand new spark plugs and you know your engine's in good condition, you don't have any cylinders with poor compression, good valves, and you put spark plugs in that are all been gapped to the same gap. When you start the engine up, all your spark reference numbers should be fairly similar. And in a case like this, when you see up here, your cylinder average is 133. But in this case, your engine average is 119. And so this one is actually reading high, but this spark offset, somebody for this slide presentation has taken a snapshot and bumped it up by 15 points. So if you would take 15 points off of the cylinder, which is cylinder 2B, you would actually be 133 minus 15. You'd be a lot closer to this 119 engine average. So this is typical of something you might see if you had one spark plug with an extra wide gap, or you had a cylinder that had lean combustion, something that would drive up that cylinder number. So once you get all of your cylinders equalized, then you can start looking at all the features that will allow you to do some meaningful interpretation with the spark reference number. So this allows for the implementation of the thresholds, and these are all selected by the user. These can be anywhere you want to put them. You can look at individual cylinders and engine-wide conditions, and you also have the ability to graph these numbers. This shows some graphs. The cylinder 2B, the instantaneous cylinder average, engine average. You can look at the different logs in a time base and see what they're doing. A quick reference gives you the letter of the alphabet. You know, A is the first output, B is the second, so forth. And you can see that B, C, and D are right on the line, but you can see that A has a little bit higher than the engine average. And in this case, engine average is 118 and number A is 119. So this is only one number above. So this is darn near perfect looking at that, because it's only plus or minus one reference number. That's extremely close. We also have alarm and warning diagnostics of a primary open, primary short, and an open cylinder could be a broken wire, bad ignition coil, or bad ignition output module. And when you have a primary short, that could be a shorted wire going out to your coil, bad ignition, or a bad output module. So helps you narrow down the wiring and what's going on with your coils. We also have a low spark voltage or a high spark voltage. And perhaps, if your average voltage, engine average was 100, uh, you might set a low spark voltage at 90, high spark voltage at 110, something like that. And if it trips too often and calls you out too often, then maybe you bump it to 85 and 115. So these are all numbers that are, through a little experience, you can get the best numbers for diagnosing low or high spark voltages. Then beyond that, no secondary spark. If you were set at 115, maybe no secondary spark would be at 125. So that means that maybe your secondary lead is broken off, or your spark plug has worn extremely excessively, and you have a problem with that cylinder. So at least this points you in the right direction of diagnosing what has gone on. Um, Low from engine, that is a low from the engine average. Um, that occurs when the average spark reference number for a given output is substantially lower than the average. So high from engine, uh, again, uh, this is the difference from the engine average. That's another set point that you can set. And then we also have something called the COV, or coefficient of variation. And the COV is when the demand on a particular cylinder is varying significantly from cycle to cycle. So, and this doesn't happen too often in like a Cat or Waukesha engine, um, but in a lot of the integral engines, and this goes into the CPU 2000, when a cylinder is having combustion stability, it may, this number may be up and down and all over the place. And it just means that sometimes it fires well, sometimes it's not firing very good at all. So it leads you into at least changing the spark plug. And if it's not the plug, then you can look into fuel delivery and other factors on some of those engines. So now we're going to talk about VeraSpark, and VeraSpark is one step below the enhanced VeraSpark. And it's the first VeraSpark system that we developed. And it was typically for difficult to ignite high speed applications, or some of the smaller slow speed application with one spark plug per cylinder. Then we also have the CPU95C for Spark SI controlled equipped Cat 3500s. And these are both available with the VeraSpark features. The 95 system gives you this VeraSpark gives you an ultra long spark duration mode, and that's designed to give you ensure combustion stability by reducing misfire. And you have to use the red coils. It gives you the fast rise time of capacitive discharge systems with long duration of inductive systems. We came out with this when a lot of competitors were introducing inductive systems, and the inductive systems with long duration had some advantages in some cases on some engines. So we made this system to compete with that and give you all the advantages of the fast rise time of the CD ignition, long spark plug life. So it's pretty much put any of the inductive systems out of business. So same EPROMs used in the VeraSpark as in the standard 95. In the three graphs you see here, this is standard duration of about 400 microseconds. This is the VeraSpark with about 2000 microseconds. You can see that duration of when it fires to when it actually turns off is quite a bit longer, about 5 times as long. And then the inductive system, it was about equal in that 200 microseconds. And what you see here is a slow rise time, and that's where we do a lot better with our fast rise time with the CD ignition. So it's been proven over the years, inductive ignitions have pretty much gone away on the industrial engines. So CD ignition is still the gold standard out there. So it's VeraSpark, ideal for engines with poorly mixed air fuel charges or high-speed engines running at light or offload conditions. And that's limited to single plug per cylinder engines, and you have to use red coils. Can't power anything from the shutdown lead. Double strike capability in the standard 95 system is replaced with the VeraSpark strike. So if you go from single strike to what would it be double strike, now you would go into the VeraSpark strike with that contact closure. You can enable that locally, serial, or via the miscellaneous input switch. Now the 95C system for CAT 3500 series engines, it's a custom CPU 95 system replacing the existing ignition system on SI controller equipped 3500 engines. And that originally was the Ultronic 3, and the interface AIB was Ultronic Interface Box. It was similar to an Ultronic 3 CPU, and that eliminates all the ignition system related moving parts like the 3 and the synchronization and such. So it's a great way to upgrade for the CAT 3500. Serial communications and configurations, all the display and diagnostic information is available remotely. Keypad accessible features are available remotely. RS-485 communications enable integration with PCs and PLCs. The standard CPU 95, which is obsolete, had ASCII protocol. The enhanced CPU 95 has Modbus RTU and USB. So you get all of them with the enhanced variation of the 95 display. The enhanced display, this is the back of the unit and the connections, and the power and the communications that comes from the ignition power module, these 4 wires, and also the shield is terminated back at the ignition module. Then we have for communications, external communications, 45, you don't have to use these, the miscellaneous input, and then the current loop if you're using that. And the USB port on the back of the unit, it's the USB type B, which is typical of a printer cable. The other end of the cable would be a USB type A, and that's what would plug into your laptop. And that allows you to program the CPU 95 EVS. On our website for terminal programs, the 95 and 95 EVS, the current version is 1.4, and you can program either standard 95s or 95 EVS with this terminal program. So this is a download from the website. So the terminal program configuration page, these are the values that are selected, and node ID to communicate with the unit, the type of output module. It could be a enhanced VeraSpark, it could be a standard 950/16, the firing pattern code, which comes from the application list, the number of gear teeth on your engine, current loop range, whether you use the RPM map, and if this is a superior, if you do choose this, you would come up with a map over here to fill in of timing versus RPM. Enhanced features, if you choose yes, we have a screen to show you that. Cylinder offsets, that's not typically done, but capable of doing it. Individual cylinder offset range, this is just a default put in there. Your overspeed setting, your timing, your one-step retard, where your reset pin is located, energy level 1, and multi-strike no. These can all be selected through the keyboard, the display module. So no matter, this is just the default when you initially start it up before you use the keypad. And when you choose the advanced features and you click on this and choose yes, then you have these three things to do. This is one-step timing retard. And if you choose none, there is no one step. And you can choose it when you're less than 250 RPM, which is just for startup. Once it hits 250, it goes back to full advance. And also you can choose to be active when the miscellaneous input is grounded. Then you also have energy control, active when RPM is less than 250, or active when the miscellaneous input is grounded. And this is the different energy levels. And then the multiplier below 250 or when miscellaneous input is grounded. So those are the choices to choose initially when you program the unit. So once the terminal program has been programmed, you will get this monitor adjustment page, and it tells you how it's been programmed with the program, the unit, the date, and so forth, whether there's a 4 to 20 RPM retard. You can put in the location, engine number if you like. And this is all saved onto the EEPROM. If the engine or the ignition would fail, you can swap that EEPROM to the other ignition unit as you replace it. And there's other options with the display module, which I'll show you. So once you're started and you're in this mode, any of these, you can change the engine timing, the energy level, multi-strike, overspeed, reset pin location, value protection. If you turn this on, stop users from making changes from the keypad, loop retard on or off, RPM retard on or off, and then the one-step retard, and you can turn that on or off. And then if you need cylinder offsets, individual cylinder offsets, you can do that with the up and down arrows over here. Now the EEPROM, when you look at the application list, it's going to tell you what the EEPROM code is for the application. So you're going to choose that like an H4A. H, if you look at the alphabet, 8, that's an 8-cylinder. 4, it's a 4-stroke. A is an even firing. So if it's a different letter in the firing pattern code or the application list, that's where you would select that there. Number of teeth, F, if it's a if you've chosen the 95, that's either the 950, 952, or 958. If it's a G, that's the 955, that's the CAT ignition module. And then the next letter is the number of degrees for the timing curve code, or whether it's programmed at the factory or whether it's programmed at a distributor level or no timing curve is programmed. You can add a number there to identify it. And then there's a code that's generated through these numbers here. They're all additive. So when you have a 5, that's the number 1 and the number 4. So when you ground the miscellaneous input, you would have the VeraSpark turned on, and then number 1, you would retard the timing. So that's how this one's been chosen. The Spark Diagnostics page. This gives you the output letter, first output, second, how they're wired through the firing order, and the raw number, and then the cylinder average. This might change very rapidly, but this one's going to be filtered a little bit. And then also if you have primary open, short, all the different diagnostics in this column. And it would give you an X in here if you had any of those faults. So the other thing with this 791.909 is that you have the ability to back up the EEPROM into the display. So it's going to store everything that's on that EEPROM, the number of counts per crankshaft revolution, firing pattern, custom timing control, everything that you programmed into that EEPROM. Once you program the ignition unit, you can swap that EEPROM from one unit to the next, but with this enhanced display module, you can clone it, which means that you load it back into the display. If you would replace the output module, then all you have to do is to go into the program and you can download that back into the CPU 95. So it eliminates the need for a tech to have his laptop out there, makes it a little simpler in many cases. So the data logging function stores up to 100 time and date stamped data logs, stores the Spark reference number for each output in the first in, first out fashion. You can access this via terminal software or the Modbus USB. The unit can be configured to generate a data log upon a timing adjustment also. Ease of retrofit. The coils are used between the 3, the 90, and the 3 CPU. So typically the coils don't have to be replaced. Electronic pickups and pickup cables are retained if you had a CPU on there. CPU 95 mounts in the same footprint as a CPU 90, so it bolts right in. CPU 95 display module mounts in a panel or remotely where convenient. Now the 95 EVS VeraSpark give you a system overview, and it's going to look much like the 95 with a few additions here. It's 3 modules instead of just the output and the display. This is the output module, blue in color versus the gray. Blue power supply module, and this takes up to almost 10 amps in and changes it into a higher voltage that can be utilized because we're doing a lot more things with the energy going out to the coils, and we'll show you what that is. And again, um, this, more is not always better. If you put one of these on an engine that is just stoichiometric and doesn't need a lot of energy, and you just pump all that energy into the spark plugs, you're just going to have shorter spark plug life. So all of these choices of the energy levels are balanced between need and application, fuel quality, um, how lean the engine runs, and such. It'll do everything that any ignition has ever done in the past. Has more energy than anything ever developed. So almost the same as any 95 in setup and everything else, except the hardware is a little bit different. The output module and display is still the same. What you'll see that's a little bit different here is that the power goes into the output or the power supply, and then that goes into the unit. So you don't take DC in directly here. And then the uh, interface, because many of these are for Caterpillar and other engines that you're replacing their own um, detonation sensing systems. Uh, Many times we have to go into one of these uh, adapters that'll condition the signals so they could go into the DET system, detonation sensor. So the VeraSpark technology and the Spark profile, we call these Spark profiles now. We don't just call them energy level and multi-strike because the profiles are different and quite a few different ones. There's 8 different optimized profiles and it's pre-selected and made available for use by the keypad selection. We can always develop different profiles, but we haven't needed to do that yet. And then you can activate these profiles based on switch contact, closure, Modbus, or via the keypad. So the very first one, this is similar to a CPU 95 single strike, and as it fires, it's got a certain duration, but this one has up to about 300 millijoules of energy, so it's more potent than a standard CPU 95. The second one here, this is similar to a CPU 95 multi-strike, and that's going to give you 2 different strikes, and this one's 450 millijoules. The next screen here is E2 single strike. Um, This is a medium current signal spark event, but you can see the current force through the firing, which is this duration here, is going to alternate, and that's 1100 millijoules. This one with individual strikes, with 3 strikes, 1 high current and 2 medium current sparks, 600 millijoules. And this one's 1780 millijoules, 1 continuous firing, going to pump some current through it. Quite a bit of energy there, 1780 versus 300 to start out with. And then this one's 860 and this one's 4 strikes. So we give you a whole bunch of different variations that allow you to tailor the spark requirement to the conditions of your engine. The 95 EVS VeraSpark for Caterpillar EIS ignition systems. This is where the coils are underneath the valve cover. And that system, again, it's an EVS, looks like the other one. The exception is that the output harness that goes out typically to the coils will go into a junction box, which is specific to this EIS system. And from that goes out to the what we call the EBC, or engine block connector. And this is the connector that goes through the block and goes into the wiring that goes to all the coils that are under the valve cover. So this is that unit, the 963-16E. The E is the calibration, because those coils have a different inductance and resistance than the standard ultronic coil. So we had to calibrate it so that the spark reference numbers would come back properly. So that's why you have to use the E. So this is a variant of the 95 EVS for Caterpillar engines equipped with the EIS, which is the valve cover under the coils, or coils under the valve covers. Gives you all the same capabilities of the standard EVS system. You need the 3 components specific to this are the Easy Rail ignition output harness, the Easy Rail J-box, and model specific J-box to engine block connector. And that's all in the application list. There's a special section in application for the CAT EIS and the EVS system. So the rest of it is, it's all made to be plug and play so that you don't have to do any specific wiring for those coils. This is a picture of the CAT engine with that EIS system. You can see that there's no coil that mounts through the valve cover. This is the output module. This is the J-box. And then you have the engine block connector. You have the cable between the ignition and the J-box, and then the engine block connector goes out here and then over to the engine itself. Okay. That concludes the CPU 95 section. Now the CPU 2000, we're going to skip over a lot of the diagnostics because they're identical to the 95. So we'll show you the ones that are different and sort of highlight how the system is different. And the CPU 90 and CPU 2000 came out in a similar time frame, and we made advancements in the 90 to the 95. We advanced with diagnostics, adding the diagnostic module in the 2000, and back and forth. The features incorporated between the two were always rolled into the other product. So with all these systems, you have the ability for variable energy levels and multi-strike. One of the differences between the 2000 and the 95 is that the 95 had double strike, where the 2000 has multi-strike that's 4 strikes. And because it's going on a bigger integral engine, and the coils are different, and sometimes there's 2 coils per cylinder, the energy levels or the voltage going out to those coils is also much higher. So this is a higher energy system than the standard 95 because the demands of a larger bore, uh, sometimes poorly mixed 2-cycle engine, which is the majority of the applications. So the picture here that you see is the diagnostic or this logic module, and this has all the brains in it. This has the EEPROM in it. This is where the keypad and all your interface resides. And that logic module is where your power comes in, your 4 to 20, because often these engines change timing up to 48 degrees during a startup cycle. Um, when we first released it, you went directly from the logic to the output module, and later on we introduced a diagnostic module, which gave you all the Spark diagnostics, secondary and primary diagnostics, like the CPU95. So this basically, if you didn't have this, you unplugged the cable between these, plugged it into here, and then plugged another cable in going there. So it was a quick, easy retrofit, just hooked up in line. And almost anybody who installs a new system today always uses the diagnostic module because it gives you all the nice things that are available with the Spark diagnostics. The other thing on the output module is that many of these engines, they're rarely more than 16 cylinders, but 32 outputs. Most of those large engines have 2 coils, 2 spark plugs per cylinder. So in the case of the old Ultronic 2, typically you would wire 2 coils in parallel, and one output, or the A output, went and split into 2 and you fired both coils, which divided the energy between the 2 coils. Well, with the CPU 2000 and using a 32 output or 2 outputs per cylinder, you get the individual diagnostics, but you also get the higher energy level going into those coils. So again, those engines often needed higher energy levels. So with the 2000 and the way it's configured nowadays, you get everything that you ever needed in outputs and output energy. Inputs, shutdown condition switch, miscellaneous input. Um, could short the ignition or tell it to shut down input. 2 meg pickups, crank position and reset, Hall effect if it's on a 4-stroke, 4 to 20 going in, and you also have serial Modbus or ASCII. 16 or 32 outputs, you got the fire confirm, alarm condition, fault switch, RS-45 serial data, just like the 95. Display capability, spark characteristic control, global and individual timing, diagnostic test and alarm capabilities, serial communications. And when we say ease of retrofit, the 2000 uses the same coils as the Ultronic 2 CPU and such. So you don't have the added cost of replacing the coils. The display, much like the 95, tells you that it's firing the energy level 2 multi-strike, your RPM, your value of your 4 to 20, and your ignition timing. Also gives you the ready syncing firing and the associated switches with the fire confirm. Tells you if it's stalled, if it's shut down with the external switch, whether it's a warning or a fault. Same level. Between the products, we try to keep things consistent, warnings, faults, all of the displays. If you know one of these products, the other's almost identical. The 3 selectable energy levels, low, medium, high. Remember the other one was like 75, 100, 125. This starts out at 125, 150, 185 millijoules. So again, it's much stronger than the 95 standard variation. Timing control, you can do it through the keypad, through serial, through 4 to 20, timing versus RPM, or the miscellaneous input. Miscellaneous input, you can just like the 95. You can make it do a one-step timing control, spark energy control, multi-strike. And the other thing that we did on some of the Ingersolls, they used to have a large disconnect switch where they would start the engine on two spark plugs, and then after it was started and running, they would shut one set of them off, and that was a large mechanical switch on the engine. So we incorporated that feature into that applications, and that allowed them to do away with a highly maintenance intensive large mechanical switch on the engine. So that is what we mean by the spark plug disconnect. Two-tier diagnostics, warnings and faults, exactly the same as the 95. Low outputs on A side, current loop out of range, primary fault, gives you the letter. Gear tooth faults, reset pickup faults, Hall effect faults, ring gear faults, wrong number of teeth read. Overspeed, that's the same. This one's a little bit different than 95, where you have a different logic board, where it says bottom board microprocessor checksum failed. So if it's an internal check, and if that checksum doesn't add up, then it's going to turn itself off and tell you that you've got a problem in that logic module. So the diagnostic module gives you significant troubleshooting capabilities. Uses the ignition coil as the sensor. There's nothing external. User adjustable thresholds enables the system to be used on any engine. And again, it gives you the cylinder average value, the instantaneous number, the engine average, instantaneous value over here. Yeah, engine average right here, cylinder average right here. It also gives you the ability to select a bar graph between the low and the high set point for the cylinder. So it gives you a quick, easy view of where you're at between the ranges. Tells you whether you have a primary open or primary short, high spark voltage, low spark voltage, low from engine, high from engine, no secondary spark, exactly like the 95s. And then we have the COV, which is the coefficient of variation. And that's, again, if that's bouncing around, that tells you that your stability in that cylinder, that, one time you have, a COV of 9, that's basically bouncing 9 numbers, telling you that one time it's low, one time it's high. And if it's very stable, plus or minus 1 or 2, pretty normal. But if it starts to bounce around, number gets larger, you have a problem with stability of combustion in that cylinder. So the summary of this diagnostic set points: we got low spark volts, high spark volts, no secondary spark, low from engine, high variation. The 3 data display screens are available when you have the diag module. Gives you a quick and convenient overview of the monitored condition. We have bar graphs of the spark reference number, bar graph of each output displaying the difference between the spark reference number and the calculated engine average, and then a bar graph of each output displaying the relative magnitude of the COV. And this very firmware version 2.1, that's at least 15 years old now. So anything in recent history will have 2.1. If it's an older unit, all you have to do is upgrade the firmware and in the unit, and it can have version 2.1. So it gives you the bar graph and the letter designation on the first display screen. Second display screen, difference between the spark reference number and each output, or the engine average. And then the third one, this is the COV. And if you looked at this one, you might say A, and go to the individual and see what that number actually is, and look at number H and see what the numbers actually are. And maybe you ought to look at the changing the spark plug on A and H and see if it settles it down. Or maybe you have a fuel injection problem. So at least it brings your attention to some problem that may be existing on the engine. It could be a bad spark plug cable, but something's going on there. If we back up to the previous screen, again, these numbers B and G aren't too high, but number M, something's definitely going on in that cylinder. So it brings your attention to problems that are on the engine that otherwise, with the older ignitions, before you had these diagnostics, you wouldn't know that anything's going on until you had some kind of a failure, or you stalled, or you something else led you to bring the attention to that problem in that cylinder. So serial communications, all the display and diagnostic information is available remotely. Keypad accessible features are available remotely, and RS-485 communications enable integration with PCs and PLCs. Terminal program monitor adjustment page looks very much like the 95. This is a summary of how it's been programmed. Node number, it's firing right now, engine's running, the timing, the energy level, multi-strike, overspeed, reset pin location, manual adjustment, loop retard, diagnostic modules turned on. This is the Spark diagnostic page. This tells you that the cylinder average is right around 200. Cylinder COV, those are all real good. And nothing too out of the ordinary here, other than this output T at 234 when the others are much closer to 200. So the EEPROM in the logic unit stores all the engine specific information. So if you had to swap the logic module out, you can remove and replace the EEPROM, swap it from one to the other. It's the typical program values that we've used in CPUs ever since the beginning. We can do it at the factory or in the field using the electronic terminal software. And the terminal program configuration page, you select the output module, the program, firing pattern, gear teeth, everything else that's going on with the ignition, typical of programming any of the other CPU 95s that we looked at. And prior to this adapter being made available, you had to use a 9-bit computer, which is the method of communicating to the original CPU 95s and the CPU 2000s. But that required you to have a native serial port on your laptop. And very, very few laptops have native serial ports anymore. So we made the CPU 95 able to be programmed through that new enhanced display module through the USB connection from a laptop to the USB on that enhanced display module. But this one, it's only been since about 2 years ago. Date on the bulletin's 11/10/20, and we've had this adapter, and you have to download a terminal program. And this bulletin 523 explains how you have to do it and all the settings on there. But this plugs in USB on your laptop. This plug goes directly into the CPU 2000 and allows you to directly program the CPU 2000 with this adapter. So To make things simple for yourself, this is the best way to do it moving forward with the CPU 2000. So the ease of retrofit, again, this pertains to using the original coils from a positive ground Ultronic 2 CPU 2 into the CPU 2000. Pickups and pickup cables are retained if you had a 2 CPU. Output module mounts in the same place as the 2 CPU. Display module mounts in a panel or remotely where convenient. And this is pretty much the gold standard on the integral engines and pipeline applications. So that concludes our presentation. If there are any questions, you can always, if they're long, you can always email me, thomas.smith@ultronic-llc.com, or you can give me a call, or you can ask your questions now.
Questions for Tom? Thomas, thank you. It's excellent as usual.